Hello, my name is Andres Cordova, and I'm going to talk about a simulation scheduling in food industry application. This is my problem description, and the article introduces a manufacturing plant that produces three types of coffee type A, B, and C, with some constraints in the simulation. The system experiences delays in production due to lack of containers, and this means loss of profit and an increase in the cycle time of the production, or TIS. The plant has different types of machines, like roaster machines, silos, containers, mills, and packing machines. This is my Simio model implementation, and for the implementation, I use one roaster, 8 silos, 2 mills, 6 containers, and 2 packing machines. This is my model with 3 types of coffee, A, B, and C, with the roaster machine, the silos, the mills, containers, and the packing machines. But the hard part of this model was the processes, because I had to use 2 different types of process, one for the container and one for the silo. And here in data, I have the different type of coffee and the time that they spend in the server for the container and for the silo. Another problem that my model had was that the entities randomly picks a server instead of going to the server that is not working. So in order to overcome this problem, I used routing groups. And I defined where the entity has to go, depending on the server. So as I described before the constraints, the processing time in some machines are not similar for each entity. So that's why I use processes. And also, Simio only sends the entity to random servers. Therefore, a route sequence is required to send the entities to the servers that are not working. And that's why I use routing groups. And also, the entities are batched 8 by 8. This was my result for the replication of the article. These are my NIS and my TIS. For the experimental case number 1, due to the lack of containers, the factory will need to buy more containers to reduce the timing system, increasing the total production. So what I did was I added 2 more containers to my system in order to accomplish our goal, that is to reduce the timing system. This is the results from my case number 1, the numbering system and the timing system for coffee A, B, and C. Also, you can see that the numbering system and the timing system for coffee type A is lower than the others. It is because the coffee type A has a higher priority than the other 2. For the second experimental case, we have the same problem, that is the lack of containers, but this time the factory will get a better scheduling program for raw material, in a way that the TAS, or timing system, decreases in order to increase the production. So what I did, I used rate tables in my Simio model. I'll show it to you in data. I create 3 rate tables, one for each entity, and I set my rate tables at 9 per hour, depending on the hour, and so on. And these are the results from the experimental case number 2. Here we have the NIS and the TAS. For this case, the TAS and the NIS are higher than the other 2 cases, but this can change with a better schedule. Also, in this case, the type of coffee C has a higher NIS and TAS because it has a lower priority than the other 2. For my conclusions, I had that experimental case number 1 will be the best option to reduce the timing system and the numbering system. Here I have a table with the timing system and the numbering system for each type of coffee and each type of model. And as we can see, the numbering system and the timing system in the experimental case number 1 is a bit lower than in the other cases. For this reason, it will be the best option to implement. Also, the simulations are a useful tool when a company wants to make any decision that requires a great investment. And when a company wants to increase production, the most important objective is to decrease the timing system, TAS, and the numbering system. So the things that I learned in using Simio is that now we can replicate and improve any model with a Simio simulation and gathering data from external sources. Also, the TAS and the NIS are important in any simulation model and in real life. And sometimes, an efficient scheduling is more important than to buy more machines. Thanks.